first couple was for you to label your reject date 0 and find your critical value for it, your cutoff value. Okay, and the shaded in part is the reject. The open part is your failed to reject date 0. So you had to find your critical cutoff. You had to do it when the variances were equal and when they're not equal. They're slightly different. Slightly different. So you have a smaller area over here. It's slightly smaller when it's unequal variances for your population. You're taking your smaller N1, and there could be a discrepancy between your two ends. So it gives you a little bit less room for error here. Is everybody okay with this? Can everybody access their table to do this? This is table 5 or inverse T. If you use inverse T, don't forget to divide your level of significance in half when you have a two-tailed test. Also, your table always returns the positive. Your calculator always returns the negative. So just put it in the appropriate places. And again, your tail is based on your HA. So I gave you 3, an equal, a less, and a right. We're good? Okay, your variance is equal, they affect your degrees of freedom. Okay, number 9, I took number 9 away, right? Right. I went right to the word problems because they make more sense than looking at the other problems. All right. A magazine claims, here comes your claim, that the mean amount spent by a customer at the burger shop is greater than the mean amount spent by a customer at Fry World. The results for their sample is in the little box there. At a level of significance of 0.05, can you support the magazine's claim? Assume your population variances are equal. That has nothing to do with your claim. Your claim is that the mean 1 is greater than the mean 2. Make your burger shop be 1, make your Fry World be 2. Take your information out. Keep it in the box. If they don't put it in the box, put it in the box. You're going to enter it exactly like this in your calculator. Okay. Find your cutoff value. You have a right-tailed test. Find your cutoff. Because your variances are equal, you're going to add your ends together and subtract 2. That's your degrees of freedom. Now, Brianna brought up a good point. When she put this in the calculator, when they're equal, your degrees of freedom comes back the correct way. When they're unequal, it doesn't come back the right way for some reason. I'm not sure what, but I'll look into it. It's not even close, and it's decimal. But make sure you understand your degrees of freedom. So we add the 22 plus 30, and we subtract 2, and we get your degrees of freedom is 50. If you use your tables, you need your degrees of freedom. If you use your calculator, you need your degrees of freedom. So either way, you need that.
But I thought you only had.
What? Don't ask it.
Oh yeah, but it's not equal.
They're equal. Your population variances are equal. That has nothing to do with your claim. Your claim is different than your population variances. In other words, they're saying this. We do know a little bit about your population. You gave me all the sample information. We do know that your population variances are equal. We don't know what they are. Like in the Z-score, we knew what your population standard deviations are. We don't know what they are. We know they were equal. If your variances are equal, your standard deviations have to be equal. But we don't know what they are. So we're going to use your sample one, but we're going to pool our ends together. Okay, so there's not enough evidence to support the magazine's claim at a level of significance of 0.05 that the mean amount spent at the burger shop is greater than that spent at Fry World. Good? Great. Hang in there, guys, because this is the end of everything you need to know. This is the last test. Yes, this is it. Well, Monday you're taking a test, and I'm giving you your reviews, and then Wednesday we start reviewing. Is there a vocab? I didn't give you vocab for chapter 8. Okay, a marine biologist claims, here's your claim, that the mean length of a mature female pink sea perch is different in fall and winter. Okay, different is not equal. A sample of 26 mature pink sea perch collected in the fall has a mean length of 127, and these are all your samples and standard deviation from the sample, and then they sampled 31 on the other one, so make it a 1, make it a 2. Okay. You have a level of significance of 0.01, and your variances are equal. So you're going to add your ends together and subtract 2. Now, when you add your ends together and you subtract 2, you get 55. Your table does 50 and 60. Technically, if you took the 50 and you took the 60 and you added them together and divided by 2, you'd get the answer for 55. But the book says if it's not in the table, use the smaller one before that. So you would use 50. If you use your calculator for inverse t, you find the exact value. You'll find this. Did you use your inverse t, Leslie? Did you use a table or your inverse t? Use my inverse t. Did you get this one? Yeah. If you use your inverse t, you get this one. If you use your table, I wasn't thinking when I did this, and I always use my calculator. If you use your table, you're going to use the one at 50. So who used the 50? Danielle, what'd you get?
2.678.
Okay, notice they're slightly different. So if you have a number of ways to do this. Inverse t gives it to you exactly. You could average the 50 and the 60 because it's smack in the middle. We call that extrapolating. We extrapolate a number out of your table. They're halfway through, so we can do the halfway mark. Or you can just use the lesser, the one a little bit less than that. So we reject. Do we reject? We reject H0 because it's to the right of your high end there, and there is enough evidence. If we reject the H0, there's enough evidence to support the marine biologist's claim that the mean length of the perch is different in the fall and the winter. Now, the reason why this is an independent sample versus a dependent sample, it's because you're not sampling the same exact ones. We're not doing the dependent sampling. A dependent sample would say, I took the same 26 of them and I remeasured them. But we didn't. We took one group from one and a completely different group for the other. So they stayed independent. Do you see the difference? This was a good example for that. Because we're not doing the dependent ones. For a very good reason. If you look in your book on 8.3, just turn the page slightly. Turn page to 439. These are when your samples are dependent. You would have to do all that information. You would have to use you could use your L1 and L2 to find your standard deviation, but you have to use their formulas. Except for standard deviation. We could use our calculators for that. But you would have to use the rest of their formulas. If you look at 441, their T formula, you would have to use that. So I avoid doing the dependent. Independent is good so that you just get a smattering of your two samples. So number 17 claims that the wage in Allegheny is greater than that in Erie. So Allegheny, U1 is greater than U2. There's their sample information. You have a right tail test. Everybody good with this? Everybody can put this in your calculator. Your variances are not equal, so therefore you take the smaller n and you subtract 1. That's your degrees of freedom. So there's enough evidence to support the director's claim that the wages in Allegheny are greater than those in Erie. Stop me if you have any questions. And the last one, did I give you 19? No. Okay. So, does anybody have any questions on these?
Yeah, the last one I got like.
I lost my touch.
That's a 3.195.
That says 3.195.
Yeah, I got.
So did you use a t-test? Just to have it in your calculator? So you have, oh, that's 49,700. 700. 88, 19, 42, 51. So you're close, but that's why. Yes. 1.61. 1.761. I must have had the 7 here, because there's a space. It's like it didn't write. Yeah. And like it didn't write there. Because the other day I noticed I had N1 and N2, and then my N didn't show up. So there, I must be maybe hitting it with my hand or something. Thank you. Okay, no questions on this. All right. Now, make sure. Oh, I said 19. Okay. All right. They claim that it's the same. If it's the same, they are equal. So you have a two-tailed test. Your variances are not equal from your population, so you're going to take the smaller n, subtract 1. Your degrees of freedom is going to be 17. You're going to look up in your table, two-tailed test, 0.10, and find your critical values. Then you're going to put this in your calc, and you're going to fail to reject H0. So there's not enough evidence to reject the claim that the households in those two counties are the same. Okay, there's enough evidence, not enough evidence. If we fail to reject H0, that was the claim. Good? All right, now, what I want you to do